So guys, we are going to solve a system of equations x plus 3x minus y over x square plus y square equal to 3 and y minus x plus 3y over x square plus y square equal to 0. Okay, so let's mark them by 1 and 2. You know what, I'm not going to solve in a typical way, that's quite boring. Let me teach you a very interesting way. So guys, I hope you have heard of complex number. Just like whole numbers, real numbers, there is also complex number. Okay, and they have a format that is z equal to, okay, x plus iy. Okay, we call z a complex number, and it has a format like this, where I is called a imaginary unit and the value of I is root over minus 1. Okay, where x and y, they are real numbers, they are called real parts. Okay, that's it, you don't need to know much for now. Okay, so we are going to solve this equation using this complex number concept. So what we are going to do here is we are going to multiply the equation 2, okay, by I. So that is yi minus x plus 3y over x square plus y square, okay, into I, that is equal to 0. So 0 into I, that is 0, right? Let's mark this equation by 3. Now guys, we are going to add the equation 1, okay, and 3. So we'll get x plus 3x minus y over x square plus y square, right, plus yi, okay, minus x plus 3y over x square plus y square, okay, into I, right, equal to 3 plus 0. All right, so guys, next line is x plus, so we are going to write this x and y together, okay, plus, and from these two terms we can take 1 over x square plus y square common out. So we are left with 3x minus y, right, minus, so notice here this I will be multiplied with this x and 3y both, right. So this is minus ix minus 3yi, okay, equal to 3. So next line is x plus yi plus, so we can put this x square plus y square in denominator, right, and this 3x minus 3yi we are going to write it together. So 3x minus 3yi, okay, minus y minus ix, right, equal to 3. So next line is x plus yi, right, plus, so from here we can take 3 common out, so x minus yi, right, minus y plus ix, we are taking minus common out, over x square plus y square equal to 3. Guys, I think this one is right. Okay, this is in correct format. Actually we want the complex number representation in x plus iy format, so this one also okay, but this one is not okay, right, y plus ix. We want this imaginary part with y, so let's rearrange it. So y plus ix, right, whenever you have something like this and you want this I will be associated with y, right, what you can do is simply, you know that I already told you that it is root over minus 1. Okay, so I square equal to minus 1, so simply minus I square equal to 1, right. So we can write here minus I square, right, that is 1 into y, we can definitely write it, plus ix. So next line is ix minus I square y, right. Let's take I common out, so x minus yi or iy. I hope you understand. All right, so let's replace y plus ix, this one, with this value, right. So guys, x plus yi plus 3 into x minus yi minus I into x minus yi, right, we just replace it. over x square plus y square equal to 3, right? So next line is simply x plus yi plus 3 into x minus yi over x square plus y square. We can separate them, right? Minus x minus yi over x square plus y square into I equal to 3, right? So guys, now remember z was equal to x plus iy, right? So the inverse of z will be 1 over z equal to 1 over x plus iy, right? Basically just like irrational numbers, we always try to free our denominator. So same logic will apply here. So to free our denominator, okay, from imaginary part, we are going to multiply x plus iy, okay, with x minus iy, right? So x minus iy also be in numerator. And now this is simply, x minus iy over, this is the formula of a plus b into a minus b, right? That is a square minus b square. A square is here x square minus b square. B square is yi whole square, right? You can easily understand it's I square y square, and I square, that is minus 1. So that is minus y square. So this will be ultimately plus y square. So now notice here, this x minus iy over x square plus y square, we can replace their same, right? This one and this one. So we can replace this one by 1 over z, and also this one by 1 over z. So let's replace it. So guys, next line is x plus yi, we can replace it by z, right? Plus 3 into, this one is 1 over z, right, minus 1 over z into y equal to 3. So now we can multiply both sides by z, right? Then we will obtain z square plus 3 minus I equal to 3z, right? So guys, now we can see that this expression gives us the quadratic equation, right? So let's solve it according to quadratic formula. So z square minus 3z plus 3 minus I equal to 0, right? And guys, if the quadratic equation in the form of x square plus bx plus c equal to 0, right? So their root is minus b plus minus root over b square minus 4ac over 2a. So according to this formula, we are going to solve this equation, right? So it is simply here minus b, so that is minus 3, right, plus root over b square, so minus 3 whole square, okay, minus 4ac, 4 a is simply 1 and c is 3 minus I, right, over 2 into a, that is 1. So next line is 3 plus minus, sorry, this is plus minus guys, root over 9 minus 4 into 3 minus I over 2. So this is simply 3 plus minus root over 9 minus 4 plus 4I, right, over 2. So this is simply 3 plus minus 3 root over minus 3 plus 4I, right, over 2. Now guys, we are going to optimize this statement, okay? So minus 3 plus 4I, okay, we can write it as minus 3 plus 4I. We can write 4I as 2 into 2I, right? And if we want to form something like a plus b whole square or a minus b whole square, right, then we need to make this 2I either a or b. For that, definitely we need to have this 2y whole square, right? And as we are just adding it, we also need to minus it, right? minus 2y whole square. So let's simplify it. Minus 3 plus minus 2 into 2y, right, plus 2y whole square, okay, minus 2y whole square, that is simply 4 into I whole square, right. So minus 3 plus minus 2 into 2y plus 2y whole square, right. This is simply minus 1, right. So minus 1 into minus 4, it is plus 4, and here it is minus 3. So 4 minus 3, okay, this one is plus 1 plus 2 into 2y, right, plus 2y whole square, right. So this is the simply we can make it 1 square. So 1 plus 2y whole square, right. So guys, our root was 3 plus minus root over minus 3 plus 4i over 2, right. So 3 plus minus root over minus 3 plus 4i, as we got it as 1 plus 2i whole square over 2. So next line is simply 3 plus minus simply 1 plus 2y, right, over 2. So there are two roots. One root is simply 3 plus 1 plus 2y, right, over 2. Let's call it alpha. Okay, that is simply 4 plus 2y over 2. It's simply 2 plus I, right. Another root is beta, that is 3 minus of 1 plus 2y, okay, over 2. So this is simply 2 minus 2y, right, over 2. It's simply 1 minus I. And guys, as z was x plus yi, right, and there are two roots, so definitely we can say x plus yi equal to 2 plus I, right. From here we can compare this real part. So the pair of x and y, that is simply 2 comma 1. Basically this is the x, okay, and this is the y. So y is simply 1 here, right. And similarly from this 1 minus I we can get x comma y, that is simply 1 comma minus 1. So guys, the set of solutions for the given equation is x, y, 2 comma 1 and 1 comma minus 1, right.